This is 2018 AIME I problem number 10, and here is a view of this combo problem. The wheel shown below in this picture here has two circles, as you can see, and 5 spokes. These line segments like A, J, B, I, C, H, D, G, and E, F. And we have a point, a bug actually I should say, starting at point A. That bug walks one label at a time, and after 15 steps comes back to point A. How many ways can that happen basically? What's the number of 15 steps long paths that begin at A and they end up at A as well? Okay, let's try to see a few examples. So basically we are told that when the bug walks, the constraints of the problem tells us that the inner circle you can only walk in a counterclockwise manner like that, and on the outer circle the bug can walk in the clockwise section like that. Does that make sense? So outside you go like that, inside you go counterclockwise, and finally if you are on the spokes you can go either way. So therefore you can think of it like a directional graph, and then we need to do the counting basically. So after some practice, well, obviously there is a few options which doesn't require practice. You start at point A and you make 3 revolutions, 1, 2, 3. You are back at A in 15 steps, right? 3 times 5 equals 15 steps, and this is successful. So therefore that's a possible solution, right? So does that make sense? So you have at least one solution, right? So number of solutions, or a number of paths I should probably say, let's say paths maybe, is 1 in that case. Now I wonder if it's also possible to travel around, like starting from A, ending up in A, say with I don't know, instead of making 3 loops, can we do 2 loops, for instance, 1 and 2? So in 2 loops we go 10 steps, but then it's impossible because we're back in A. You can go like 11, 12, 13, 14. I'm 1 short. So it's not clear how this happens, right? And you can keep playing with it further, right? So, and then eventually, after playing a lot, you can probably say that, I have to, when I draw circles around this inner one or outer one for that sense, due to symmetry, it doesn't matter really. Because we go 5 steps, then we end up here in point A. If we do only 1 turn, and we still have 10 remaining steps, an even number of remaining steps, which is nice because anytime you use a spoke, you go up, you go down, and that's 2 steps. Does that make sense? For instance, we did 5 here around circle, then we did 1, 2, so we are at 7, 8, 9, 10, 11, we have 4 more to go. We can do 12, 13, 14, 15, back in A. Does that make sense? Or after we were at the 11th step, we were in point A, we could have done 12, 13, 14, 15. Again, it would have worked. But that gives me an idea that it will probably not work. So do you guys see that if I start at A and if I make 2 revolutions, it doesn't have to be like that obviously, but if you finish 2 revolutions, that's not gonna work because I end up back in A in 10 steps and I have only 5 steps left. So, well, one solution is complete the turn, the 3rd term, but if I don't decide not to complete that turn, then I need to go to the other layer, at which point I need to come back to it and things start getting complicated, right? So the first time I saw this problem, I said, hey, probably I need to do a casework. I need to divide this into simpler problems and then try to make sense of it. You can come up with different caseworks, like depending on what strategy you are using. So one of the caseworks is how many times do you go between the inner circle and the outer circle, right? And so you can go 1 time, 2 time, 3 time, 4 time, 5 time, but you can't go back and forth more than 5 times, because if you go back and forth 6 times, you know that you have 12 steps already, and in order to reach 15 you need 3 more steps, which is impossible, because the only way you can, if you are at A, you go back to A in an odd number of steps is if you make that circle, right? Does that make sense? But we already did the circle. So so we have a few things to consider, right? So casework would work, and indeed it does, if you do a casework based on how many times we use these spokes, and that's possible. And then during that casework you would repeatedly apply stars and bars, for instance. But instead, one of the solutions on AOPS I really liked. So the solution that I have is from Brainiac 1 on the AOPS forums, right? And so the idea is quite simple. What we do is we first make a few observations. So under what circumstances do we end up in A? So which label should I be at so that in the next label I can end up in A? Well, if I'm in J, then in the next step I can end up in A. Or if I am in E, then in the next step again I can end up in A, right? Does that make sense? Because so therefore, if you are in J or E, then you can end up in A. How about the point B? How can I end up in B? Well, I can either come from A or I can come from I, right? From A or I can end up in B. Let me just put them in chronological order, alphabetical order, I should rather say, right? So you can end up in A after from E or J, from B from A to I, or if you want to end up in C, you can end up in C coming from B, or you can coming from H. So you can end up in D coming from C or coming from G. And you can come up in E, for instance, coming from D or coming from F. Let me continue this way. And how about ending up in F? Well, I can end up in F, this guy, coming from E or going clockwise coming from J. From E or J. How about ending up in F, in G, and then in H, in I, and then in J? So let's quickly do that. You can end up in G, sorry for that. If you were previously at D or F, you can end up in H if you were previously in G or C. You can end up in I if you were previously on H or B. And finally, you can end up in J if you were previously on A or I. That's it. Now we can build our recursion. So let me go ahead and create some steps. Create the sketch, and then we can see how we can handle the bashy part. So what I'm questioning is how many ways can I end up in A or B or C or D or E, F, G, H, I, or J in each of the steps, right? So let's go ahead and quickly complete this table here first before I create my rows. Okay, there you go. So now, initially I didn't take any steps yet, or I can take 1 step, 2 step, and so on, 3 step, 4 step, 5, and I'll just say ... and then 14 maybe, and finally 15. So I want to see, the question is particularly asking, how many different ways can we end up inside this cell among the others, right? So I don't really care the others. All I need is how many different ways can I end up inside here. So to begin with, we know that we start at point A. So there's after no step, there's 1 way I can end up in A, and 0 ways for the other ones. Now I need to complete this table. Now remember our previous analysis. So how about the number of ways can I end up after 1 step? Can I ever end up in A? That's not gonna happen, right? If you start in A, you did one step yet, either going B or going to J, but that's it. So what we need is, so therefore this one would be 0. But where did it really come from? Do you guys see that all I did is count the number of paths that end up in E in the previous step, count the number of paths that end up in J in the previous step being 0th step, right? So therefore this 0 here is just this 0 plus that one. Does that make sense? So therefore A in the next step, AT, is equal to the value of ET minus 1 plus, we decide, and plus JT minus 1. So this is kind of a recursion, right? How about B? How can I end up after one step in B? Well, if previously I was in A, then next step I can end up in B. Or previously, if I were in I, then I can end up in B again. So therefore, B sub T is just A sub T minus 1 plus, like we said, I sub T minus 1. So this one is a J, by the way. Okay, it's not an I. This one is an I, that one is a J. And how can I end up in C? Well, let's finish this row first. So therefore, for this value here, it's the sum of this value and that value. Does that make sense? So which the sum is 1, obviously. How can I end up in C? Well, I can end up in C if in the previous step I ended up in B or H. In the previous step, the chance of ending up in B is 0. And the chance of ending up in H is 0 as well. So this guy is a 0 too. How about in D? I need C or G. So C in the previous step is a 0. G in the previous step is a 0. The final outcome, 0. How about in E? Previous step, D and F. So D is 0. F is 0. Big 0 here too. How about G? You can end, F I should say. You can end up in F if in previous step you ended up in E or J, E here or J here, both of them 0. In G, you can end up in G if previous step you were in D and F, both of them in the previous step were 0, and so on. So for instance, you can end up in H if you were previously in C or G. C was 0 previous step, G was 0, so that's a 0. Actually, life is pretty easy, right? So I shouldn't even think about it. So you can either end up in B if you start from A, or you can end up in J, right, after one step. So therefore, these are the only ones. The others would be just 0. Now, this whole thing gave us the idea, right? So we can translate this thing into recursions like this. And I didn't want to list all of them, and you can list them all if you want to, because more or less you can do the whole pattern on the picture here. And that's exactly what I'm going to do next. So let me color code the cells which create the next cell, right? So for instance, E and J would give us an A, right? So let me go ahead and do something here. So I know that in the previous step, the E and the J created in the following step the A. Does that make sense? Let's change the color. How about the A and the I creating the B? The A and the I creating the B. The A and the I give us the B. Does that make sense? And now the next one, the C, right? So let's have yet another color, so green, why not? So the B and the H will give us the C. The B and the H will give us the C. And let's move on. So new color. I'm running out of colors here, people, and I don't really like these colors, to be honest. How about orange? Yes. How about, what were we? D. So in order to end up in D, you need to be either in C or in G in previous step. So therefore C or G in previous step will lead us to D. Does that make sense? And almost there now. How about in E? Well, you can end up in E if, let's say this one. You can end up in E. Oh, this is a very powerful color now. It's not even transparent. So let's go back. Okay, let's find a new one. That wasn't a highlighter after all. Well, I have limited colors, it looks like, right? So, okay, so I will just use a pencil then. All right, so I can end up in E if previously I was in D or F, so previously I was here or here, I can then end up in E. Well, I'm not done yet. I have a few more things going on, so let's more or less handle these as well. If I were previously, so if I want to end up in F, F is here, E or J. So therefore, previously I was either in E or J, and this way I can end up in F. Does that make sense? Whew, so almost there. How about G? I can end up in G. Let's first get a good color. So how about that? Yeah, I can end up in G if I were previously in D or F. So if I were previously on D, there you go, or on F, there you are. And finally H, I, and J. Well, so many colors, so probably I should have done something sillier than that. Oh, shoot. Yeah, let's use the black. I haven't. Yeah, why not? Let's use the black color. So I can end up in H if I were previously on C or G. So C or G creates the H. And finally I and J, so let's do that as well. So maybe I need a brown color. So I can end up in I if I was previously in B or H. So B here or H here. And finally the J. The J tells us, come on. Okay, yet another color, pinky. Yes, here J is a result of A or I, right? So A here or I here. All right, do you feel lucky? Maybe. Okay, so let's finish this monster now. Now that I know the rules in front of me, I have color coded everything, I should be able to derive each of them. So therefore, next cell A, after 2 steps, how many ways can I end up in A? Well, in the previous step, because you look at that, it was yellow color, E or J. So E or J, 0 plus 1 is 1. How about the B, blue color? Previously it was these two, A and I. So A and I, 0 and 0, that's a 0. So the green, B or H. The B is 1, the H is 0, so that's a 1. The orange, 0 or 0, that's a 0. The E is, the two gray, 0 and 0. E is actually pretty nice. It's just the sum of the two neighbors, right? So it's pretty convenient. Okay, so the F is the green circle. So this one and this one, so which is 0 and 1. So, oh, that's a 1. And then the purples are these two, so therefore that's a 0. These are the blacks. One black here, which is both 0. And then the brown is 1 here, 1 here. Well, they're both 0, looks like, right? So, oh, sorry, this one is a 1 now. That's a 1. And finally, the pink is coming from these two, from A and I. So therefore, in the previous step, A and I were 0 and 0. So that's a 0. And we can go on in that fashion, right? So does that make sense? When I think about it, let me go back to this picture. Let's see if we can get some further insight. After I'm done with the first step, I realized that some of the things that I did were probably redundant. Do you agree? What do I mean? Look at that. The E and the J add up in the next step, right, to give an A, but the E and the J in the next step will also give us an F. Aha! So therefore, does that make sense? So there is some sort of symmetry there. Well, it's exactly symmetric, to be honest. So therefore, A, whatever we have inside cell A will be the same inside cell F. And actually, maybe I should have done that way. Okay, so here, this whole column is the same as this column. Because in the previous step, so how did I, okay, let's just remember, how did I end up with this 1 here? In the previous step, I added, well, let's check, E and J. Okay, so I added the E, which was 0, and the J, which was 1, so I ended up 1 here. How about this one? In the previous step, the E and the J again, which is 1. Wow, that is just beautiful. So the same thing will happen to AI here, so therefore the outcome B and J in each step will be equivalent as well. So let's go ahead and do that. So let's make it blue color maybe. The B we said, and the J. Does that make sense? So these two will have, so therefore I don't have to double count the stuffs, right? So I can just, how about the C? The C here is B plus H. The C also appears, B plus H, sorry, also, yes, over here. You have, so therefore C and I are pretty much the same thing. So let's go ahead and do that. The C here, the I here. Ooh. And what else? Okay, the D. The D comes out as a sum of C and G, but also H is coming out as a sum of C and G. So therefore, D and, oops, let's use turns orange again. Okay, so therefore the outcome D and H are the same. D and H gives us the same thing. And finally, E and G, obviously E is D plus F, but D plus F is also G, so therefore those two are the same, to be honest. So and I don't know if I have any highlighter color left. Yes, I do. I'll pick, why not, this one. So therefore this column and this column will be the same, and that's it. We have 5 pairs of columns. So therefore if I just focus my attention on the first 5, then I know how to obtain the remaining 5 as well. Does that make sense? So that would kind of significantly improve our speed in that sense. So therefore, let's choose a different color now. Now I can go pretty fast. All I need is, let me just remind myself of the formula. So C is just B and H, the sum of B and H. B in the previous step plus H in the previous step. D is just C and G. D is C in the previous step plus G. Is that right? Yeah, in the previous step. And then finally, E is D and F in the previous step. D and F in the previous step. Whew. Okay, so I hope everybody agrees on what we did so far, right? So if all we do now is follow the order. So let's start from A in the previous, E and J. E previously was, there's 0 ways to end up in E, 0 ways to end up in E and J, we said, right? So therefore, there's just 0 here. But if this is 0, I can automatically put this one 0. How about the B? A or I? A is 1, I is 1 as well, so that's a 2. And obviously, if this is a 2, that's a 2 as well. And how about the green? I meant to say the C. So in the previous step, we checked the B and the H. So the B was 0 here, and the H was 0, so this one is a 0. How about the D, C and G? D is the C, which is 1, and the G, which is 0, so that's a 1. Next is the E. E is D and F. Oh, we know already. E is the easiest one, right? It is just the sum of the two around it, so which is just 1. Oh, look, I forgot to, don't worry. So these are all, oranges are all 1. Okay, so therefore, well, orange is 1, and purple was 1 as well. So, and the green was 0. Okay, there. Very easy. I can worry it at the very end. I can quickly replicate my stuff. We're already in step 4, right? And we go in that fashion all the way until we reach step 15. And I want to say good luck to you. This is a monster. So in each row we need to calculate 5 sums. It's not that bad, to be honest. So therefore we have 15 rows, 5 sums, so it's just 75 sums, just simple numbers, adding up 2 simple numbers. Well, early on it's the numbers are pretty small, but down the road the numbers will be significantly higher. So what I did is I created an Excel sheet to help us with all these calculations. And so let's go ahead and make use of this sheet. I already entered the initial condition, so therefore remember, if you want to end up in A in the next step, all you need is, you can end up in A either in the previous step you were in J, or you were in E, right? So it's really J plus E from the previous step. So therefore all I do is I write a formula here. I say equal to, I ended up either from E or J, so either from E or plus, or I come from J. Does that make sense? And press enter. I'm done with that one. How about the B? I can end up in B either coming from A or I. Let's do it. Either I come from A or I, and enter. And now at C, I either come from B or I come from H. So therefore B or H, so that's equal to B or H. Enter. D will be coming from either C or G. So therefore this is equal to C or G. Enter. Finally, E is just equal to either coming from D or F. So you're either coming from, oops, I don't have to do that, D, yes, or F. Now the rest is, like we mentioned early on, symmetric, but let's just finish this picture regardless. So you can end up in F either coming from J, going clockwise, or you can come directly from E, so it's E plus J. So therefore it is just E plus J, and that's an enter. Now almost done. G, you can end up in G either coming from F or from D. So it is equal to number of F plus number from D. Enter. Number of paths ending in F or D in the previous step, right? And for H, if you want to end up in H, you go previously from G, or you come from C, right? C or G. So this is equal to from, oops, I don't need that. Okay, so from C, or you can come up from G. Enter. Almost there, people. Either I come again from H, or I can come from B. So therefore this is equal to from H, or I can come from B here. Press enter, and finally J. I can end up in J if in the previous step I was in I, or if I were in A. So that's just I in the previous step, or A in the previous step. So you might say, what did I do here? Well, I did something interesting, obviously. So I can just highlight this row, and all I will do is I will complete it, right? So I can just drag the, oops, sorry for that, I can just drag everything, right? So I will drag everything to the end. Okay, so how do you do that? I don't know. So let me try to do it in a different way. Oops, come on.
I can learn to understand you
oh
much
my
better if I can get familiar.
Okay, quiet lady. Okay, so I want to complete it, right? So well, that's a shame. This won't let me, looks like. So I'll just Control C. I will just copy this, Control C, and let's see if I can paste it in Excel. So let's see. All I will do is, well, I will Control V. That's nice. And then Control V. Nice. Control V. Nice. Control V. How nice. I'm super cool. Control V. I'm almost done. Control V. Yes. Okay, I need to move my picture a little bit. Control V. Almost there. Control V. Control V. Control V. Paste it. Paste it. Paste it. And finally paste it. Yes. There we are. So we are done, right? So therefore, after 15 steps, oops, let me just escape from that thing. So oops, come on. Oh yeah. Okay, so after 15 steps, therefore I will end up in A, in the cell A, in 3004 different ways. And this 3004 came out as the sum of the previous row coming from E and then the previous row coming from J, meaning it is the sum of this number and this number over here. Does that make sense? But basically what I did in my previous exhibit is I stopped after a while because I realized there is too much bashing going on. I stopped. But you should be able to, during the exam, test out all these things, right? So all these numbers, like I said, using symmetry, you know that some of the columns are replicas of each other, like we mentioned it earlier. For instance, column A we mentioned is technically the calculating, because you can end up in label A if you were previously in in E or J, right? And it is the same thing as F, right? Because the only way you can end up in F is coming from E or J, right? So therefore it is symmetric. So therefore these two columns are actually the same columns. Well, okay, so we are done with this nice cute problem. Hope you enjoyed it and looking forward to see you guys in our next lecture.